Okay, guys, I'm going to go ahead and get started here. One thing I'd like you to know, we are hiring. Couchbase is hiring. So, Deepika is in the back, our recruiter. There she is. Hello. So if you're looking for something and you're awesomely fantastic, she's a good person to talk to. And we probably have something that you can do. I put it on this slide because I'm going to be showing you a demo that's up on GitHub today. If you got Couchbase, you can go grab the GitHub repo. You can follow along at home. I'll put my slides up on SlideShare or something. But I'm going to do a machine learning demo. I'm going to give you a little background about Spark and Couchbase. So I'm Will Gardella. I'm a product manager at Couchbase. I get to work on all the good stuff. So I get to work on the big data stuff, the big data connectors, full text search, some new stuff that's coming out that will be coming in Couchbase Connect this fall. So Couchbase Connect is coming up. We know the dates. It's going to be November 7th, 6th, 7th, 8th. We're going to be here at the Santa Clara Convention Center. And so we're very excited about that. And I'll be making a pretty interesting announcement there. We'll have a developer preview of something that's brand new coming out in Couchbase. Okay, so yeah, like I said, I'll go through this real quick, but I will put this up, so if you guys want to follow along at home, this is all public. So Spark. Let me start with Spark. You guys might have seen surveys like this saying, hey, Spark is the top paying technology of all the technologies. And Scala, which is, you need that really to do good Spark, it's right up there, you know. We've seen it overtake Hadoop in terms of popularity and search rankings and so forth. So what is this thing? It's a big data processing engine. It's sort of a general engine for big data processing, and it provides libraries that let you do advanced analytics stuff. So it's scalable. It is composed of this Spark core that does the basic, most of the heavy lifting is done in that Spark core layer, and all the advanced stuff is built on top of it so that you get a very efficient, very effective thing for task scheduling, memory management, fault tolerance, all that good stuff is shared among those advanced features. Unlike in the Hadoop stack where it's different libraries, not shared, things might behave very differently. Okay. Another nice property of this thing is it's not closely tied into the layer where you execute it or store it's not tied closely to the storage layer. It's not tied closely to a model like MapReduce or something like that. So you have some flexibility there. And in fact, Spark connects to most things. You can go directly to S3. You can go directly to Couchbase. You can go directly to Elasticsearch. And you can go to HDFS, of course. It works very well with all the Hadoop stuff, Parquet files, all that good stuff. Why do people like this thing? Well, one thing is it's fast. Compared to Hadoop, it's generally faster. I would say one exception might be in the SQL and Hadoop space. There might be some things that are faster, but in general, it's faster. It's much faster for machine learning, or things where you have lots of iterations, like what I'm going to show today, much faster. But it's faster in most cases, actually. It's sophisticated in the sense that it's the thing that I did a demo on. I couldn't build that from scratch. I need something that helps me do it, and I can build that algorithm, run it on my laptop, and I can deploy that to a cluster. And I don't, I have a very nice way to get from developer experience to deploy to the cloud. And I'm going to move a little bit fast here, but if you guys, how many people know Spark and all this stuff already? Pretty good number, okay? That's good. So you can come up here and present. So, some of the things that people like about it is that you have more powerful primitives to deal with. So you have lots of functions that let you, go beyond just the map and the reduce phase, but sort of, coalesce, sort, all this good stuff. And they're just kind of easy to use. You can look at the docs, you can figure out what they do. It's pretty easy. You're not designing algorithms most of the time. It can get complicated, but it doesn't have to. Gives you lots of ways to work with data, unstructured, all that good stuff. And another thing that's really important is the unified batch and streaming. So about 5-6 years ago, when you said big data, it usually meant maybe you were going to do something like Storm for your streaming, and then you might have Hadoop with MapReduce, or maybe you had Hive, but those were two totally separate things. And I used to work at a big company, enterprise customers, and banks and people who have money. They would come in and say, yeah, I've got a data science team, it's 35 people. I have 15 who work on the Hadoop stuff and 20 who work on the streaming. They can't share any code assets. They have to do everything by, separately. And so they might be designing the exact same thing semantically, but they have to do it differently in those worlds if they need that. And so Spark kind of gets rid of some of that. It doesn't take it all over, but it really helps. Okay, so that's the Spark part, very fast. The Couchbase part, obviously that's what I do for a living. But at a high level, Couchbase is sort of a next generation database in the sense that it provides some things that businesses really rely on for sort of core mission critical functions of their business. So this is like very high level, but in terms of these next generation businesses, the things that they need are responsiveness. So this, you see Couchbase a lot where it's a sort of time is money kind of case, response times for transactions and things like that. You buy something, you're online, you're clicking, you need to see that next recommendation immediately, because if it's slow, you leave and go someplace else and do your business, right? So that's the responsive side. Scalable, obviously, people these days don't want to have the kinds of problems that you used to have. You build an application that's successful, you need to scale your database, and all of a sudden you're in for a world of pain, right? So that's something that people don't want to deal with. One of our speakers who was here one other time, before the show, he said, this weekend we spun up 600 nodes of Couchbase. I was like, you should tell everybody that. He's like, I can't tell them because it's a secret. So I was like, okay, great. But now I can tell you. Data agility, that's sort of like you have data in formats, you have changes over time, your data may change, Curtis may come up with some new features that need to go in there, and maybe those features aren't relevant for everything, and so what do you have? Alter schema hell, do you have to go in there and change everything? Doesn't really fit. People don't want to do that, right? They just want to have the smallest copies of the data that make sense, they put in what they need, they get it out again. Schemas a lot of times are impediments in these types of use cases. If they're not, that's fine, but a lot of times what you see at scale is people start to use databases in a non-relational way anyway, because it's just not sustainable from an organizational perspective. So that's something that people usually need. Of course, mobility, I don't need to explain that one. Geo-distribution for disasters, for performance reasons, you need to have the data close to where those users are and in multiple places in case you have, something goes wrong. And of course, easy to manage, right? Because everyone has lots of things to do. So we like to think of Couchbase Server as the operational database for web, mobile, and IoT. Those are kind of our main things that we look at. And what we do, yes, we're a NoSQL company, but we have SQL. We combine the flexibility of a flexible JSON data model with the power of SQL, the expressive power of SQL, the fact that most people understand SQL. So you can write declarative queries instead of saying how I want to get my information out. You just say what I want and let the database figure it out. And then the scalability properties of NoSQL. So Couchbase's history is that it came from scale first. And so everything we've added on top has been added in a way that preserves those basic properties that our customers would be very angry if we broke. Okay, so I think I've talked about most of the things on here. Just going into a couple of things here. It's always at something like this, I always have to pick a few things to talk about. But I thought I'd talk about the scaling and availability part today just a little bit. Basically, when you think about Couchbase, what you want is you want to be able to develop your application, and as it's successful and as it gets more traffic and so forth, you just add nodes. You don't want to do anything to your application. You don't want to have to do load balance type maneuvers or anything else. You just want to be able to write your application to that Couchbase cluster and have it work, and have it be able to grow. And so that's kind of how Couchbase is designed. A lot of them, you have a system which is, conceptually, it's like a giant distributed hash map. You can hash any ID of something, any key of a document, and this all happens under the covers. Of course, you don't have to do this if you're developing, right? You use the SDKs, you don't have to deal with this. But under the covers, what's happening is Couchbase is able to take that client and go directly to where that document lives without having to ask anybody, right? The client itself has enough of a map that it can just go straight to the location of that document. And as a result, when you want to, you can dispense with any processing that's going to add latency, and you can go right to where something needs to be. Also, things like replication, they're all managed under the covers. So any Couchbase node, you should be able to fail that thing over, goes bad, hardware goes bad. You should be able to fail that thing over and have the rest of the cluster take over the load for you, right? So that's the kind of stuff that Couchbase is designed from the ground up. So when we do things like, okay, let's add SQL on top, then we're going to make sure that that preserves those properties. All right. And of course, what I was talking about so far is kind of inside of a cluster, but Couchbase is also known for being able to replicate easily geographically, so what we call XDCR, which is cross data center replication. You want to be able to take that stuff and replicate it to other regions where each of those Couchbase clusters is sort of, let's say, standalone, right? It can take replications from another cluster, but if California has an earthquake and falls into the ocean, then your other data centers can just take over and go about their business. I'll be upset, but your database will continue to work. And one of the things I'm going to show you today, so I decided to talk about this, was our query language. So we have a query language called Nickel for querying JSON documents using SQL language and semantics. Nickel is going to look very familiar to you if you have never looked at it. It's going to look very familiar because it's a SQL dialect, and it has some extensions that let you deal with some of the things that happen in unstructured data. So you might have documents that are missing attributes because they don't make sense, right? The wattage of a toaster might make sense, but the wattage of a t-shirt doesn't make sense, right? So you don't need to store a field that says null or have a very wide column like you might have seen in the old days if you worked at a 3-letter company. You'd have these very wide tables where they have columns that are mostly nulls, and then there's like this one thing in there, and then the users come in and put in some nonsense that they know means a nonsense value, and then you think you have schemas that tell you what's in there, but they don't really, and you just get confused, right? So that kind of stuff, with a flexible JSON data model, you need to be able to check is an attribute missing. You have a couple other things that help you deal with arrays and how you want the data to look. I'm going to show you that, so we don't need to talk about it too much. Okay, so Couchbase plus Spark. Why do these things go together? Because a lot of people, they hear Spark, and I know you guys would never do this, but a lot of people hear Spark and they're like, oh, well, that's going to be great. I don't need to use my database anymore. I'm just going to use Spark. And now I'm so happy there's a talk out there that's called, like, Not Your Father's Database, Not a Database at All, that the AmpLab guys give, or the Databricks guys. So it comes from them, and they basically explain, in detail why, how is Spark different from a database? Some fundamental architectural assumptions, the way that it works. And so this is not to say Spark is bad. I like Spark. It's just to say that they're for different purposes, and that's what I kind of want to explain. That Spark, when I say Spark's not a database, when you put these things together, you're usually doing something in this combination mode, kind of like what Curtis was saying. There's a place in there where you often have something like a fast key value store. You have something that is taking your operational load. It's taking a lot of updates, basically. These updates might be quite small, too. They might be lots of small updates. Will bought a thing on eBay. Okay, great. I need to keep track of that. And I need it to be fast. Will looked at such and such thing. Okay, that's an important event. I need it to come through to my model really quickly. So, these kinds of cases where you have a catalog, that catalog might be running, or often is running in Couchbase. The machine learning model is often getting trained in a Spark or some other similar system, and then that thing is feeding predictions or models that can make predictions, the results of predictions or models into a Couchbase, so that those things can be served really quickly. And then those things can be updated and sent back. So you have things like catalogs with recommendations. You have things like predictive analytics for personalization. What would Will like to see in his Facebook feed? The things like mobile applications with fraud detection. I'm there at the store. I'm trying to pay. Someone has to decide really quickly whether they should let me pay or not. I'm not going to go through this one because I feel like I'm in a little bit of a hurry. I want to get to the demo. So I'll just say a little bit about our Spark connector. The Couchbase Spark connector allows you to write up. I said the word SDK earlier, right? So with Couchbase, we provide SDKs in all the major languages that make it easy to write applications. We also provide connectors for some of these big data things, Spark connector, Elasticsearch connector, and so forth. And what I'm going to show you today is using that Spark connector. So this Spark connector lets you do most of the ways you can do data manipulation, access data in Spark. It will let you pull data out of Spark into Couchbase, or vice versa, take data that's in Couchbase and write it into Spark, and mix and match. Okay, so you can create. If you know what RDDs are, you can create RDDs based on key value, get operations in Couchbase. You can use these nickel queries. You can use views. On the other hand, you can create D streams out of what we call DCP feeds. So Couchbase nodes use a protocol to synchronize with each other, and we use that same protocol for a lot of things. That's DCP, so Database Change Protocol. So you can create D streams based on Database Change Protocol. And remember, I said one of the big things about Spark that people liked is that it has streaming and batch in one thing. So with the Couchbase DCP protocol, you can do Spark streaming based on what's going on in your Couchbase cluster if you want to, or you can just do jobs whenever you want to run them. And so you have all those possibilities open. You can also persist things like RDDs. So you want to store something back to Couchbase, you make a prediction, you can store that back to Couchbase. You can store D streams, which D streams just basically a form of RDD, a discretized stream, but it's a streaming protocol. You can store that into Couchbase and use it further from there. And of course, all the new stuff like data sets and data frames and Spark SQL, they're all supported. Okay, so almost at the demo. Actually, I can skip this slide. This is just showing you that often Spark is used to pull information from even farther places to build machine learning models. So it might be pulling some information from Couchbase. This is not going to be a shock to you if you weren't sleeping through Curtis's presentation. But there are other places where lots of data is stored, and that's usually not in Couchbase. Usually Couchbase is not going to store hundreds of terabytes of data, right? That's often done someplace else, and one of the reasons for that is that it's cheaper to have data that you're not processing all the time, just stored someplace, and then you load it up into a machine that can do processing on it when you need to, and then otherwise, most of the time, it's just sitting there on a file system somewhere. That's a much more efficient way to do that very big stuff, and Couchbase usually doesn't do that. We leave that to Hadoop or other things. Okay, time for a demo. Yes? Okay. Am I still popping?
I think so, yeah.
How's that? Am I mic'd? Okay. I could probably talk loud enough even without this, but I won't. All right, so demo time. Let me get out of this. So, and sign into this. So this is, I'm running actually a pre-release version of Couchbase. So if you want any exciting rumors, this UI hasn't changed in a long time. So anyway, this is the Couchbase web admin that we're looking at here. And I did this on some data that I added to Couchbase sample for the travel sample, because in Couchbase 4.5 we released a developer preview of full text search. So we needed different kinds of data that weren't in there before. So there's a bunch of hotel reviews in there. If you want to go take a look at this sometime on your own, and all you need to do is go install the travel sample bucket, which is under settings sample buckets. You can pick out buckets to install. But anyway, let's go take a look at this thing. So this is just running on only my laptop, so this is not running a full cluster. But I've gone in here and pulled the reviews out using Nickel. So remember I said that if you know SQL, you'll look at this thing and think, hey, that looks kind of familiar. There's not really anything too unusual that I'm doing here. If I were to unroll this whole thing, it would take a few minutes, but basically I'm taking documents of type hotel from this travel sample, and there's this thing called a bucket analyzer that helps you. If you don't know what your data set looks like, you can go down here into the query workbench and you can pull up this bucket analyzer. So remember I said, hey, in Couchbase land, we don't really care, if you got a document and you need to change something, we're cool with that. You just do what you need to do in your application. We store it, we let you query it, that's what we do, and you do what you need to do in your application. So that's great, and it's very flexible, but sometimes you don't know what's in your data, right? So you have to go play around with it. What this is showing you is the bucket analyzer, and my font size is really big here, so I'm not using my screen real estate very well. But you can see down here, it sort of identifies flavors of documents, right? I happen to know what's in here. There are airlines, there are landmarks, there are hotels, and other things. So I'm just doing a selecting the reviews from travel sample, the bucket, where type equals hotel, and it turns out that these reviews are stored in arrays of objects, and I don't want to get any empty ones, so I'm ruling those out, right? And I'm doing an unnest operation, which is basically getting rid of some of those layers of embedding. And if you look at the result here right now, this is pretty similar to what I'm going to do in the Spark, although it's not quite as clean. But if you look at the result down here, you can see these are bare reviews. And if you think back to what Curtis said about the word embeddings, what I want is the words in the right order so that I can feed them into a model. Now I need them a little cleaner, so I'm going to do a couple data cleansing steps here. And I want to just show you one thing, just because it's kind of interesting. You saw that element thing I had there, or values. Value is another synonym for the same thing. What I've output here is an array of strings. But if I get rid of that elements thing, what you're going to see is this is what I would get from that projection if I didn't have the element, right? So now it's more looks a little bit more like the original documents. And so, anyway, I don't want to go all the way back in time here, but that's basically this is what we're going to be working with, okay? But that's an example of some of the things that you can do when you're working with JSON through the Nickel language that help you along. So not going to look at that anymore. I'm going to go over here to IntelliJ. This sample as well, everything here is something that you can go home and do yourself if you're interested. And this is a pretty simple example, but we're going to do, this example is called Word2Vec example. So it's kind of hard to go wrong there. But anyway, this is using Spark plus the Couchbase Spark connector to build a word embedding. And you can kind of read down here. It is in Scala, which is kind of weird. But you're doing a couple steps here to set up your configuration. This here is the bucket that you want to connect to. Username and password would go there if you had a bucket password going. You need to set up some other context so you can execute your Spark jobs. And then you're going to see the SQL statement that looks very similar to what I just showed you a second ago. It's nearly the same thing. And in fact, it is the last one I just showed you. So I set that in a string for my own convenience, but it goes off over here, doesn't wrap, that's fine. I'm going to take that SQL statement, or that nickel statement, and I'm going to pass it into Couchbase. I'm going to execute on Couchbase. I'm going to do the cleanup steps right here. Now, everything in my talk ties together. It's so well thought out. I said MapReduce is like kind of build it yourself, and Spark gives you a lot of nice little primitives that do a lot of the cleanup for you. And that's really what this is doing here. It's basically saying, oh, you know what? Take these inputs and split them on the string, split them here, build me a structure that preserves this order, get rid of all the everything that's not a number or a letter. I don't want to see it anymore, right? Because I want the stuff that goes into my machine learning model to be essentially clean, right? And so that's what I'm doing there, and it's just a couple lines of Scala. And I'm getting a sequence out, which is a data structure. So then you go down here. Word to vec is a Spark, is a Scala object, and I'm gonna, in this step, basically what I'm doing is saying, if I've already trained this model, then when I run this file, just use the model and the Spark context that I serialized, that I did before, that are stored. If I haven't done it before, then I want you to go ahead and train it. And that's what this is here. So it turns out that word to vec is quite simple, unless you want to get into the parameter setting, which can be very complicated. If you just want to do what I'm doing here, it's very simple. It's that step right there. It's the word to vec.fit. That's kind of the thing you do that gives you the predictions. And then you can save it, or you can, like I said, you load, if you have one there, you load what you had before. And then what we're going to do here is we're going to look for synonyms for the word beer in these hotel reviews that are in the travel sample data set. Now, what Curtis said before, the Peter Norvig aphorism, more data beats a cleverer algorithm. This algorithm does not have much data to work with here, so it's going to give us some predictions that might be weird. So let's try it and see what happens. And it's going to just print everything out here into the log. So let me try running this thing. And let's see what happens. Let me show this bigger. So Spark is doing all the stuff, like Couchbase actually manages all the topology and all the stuff that you don't want to have to do as a developer. Spark does most of that thing. You can see word to vec is now training. It's showing you the word count. Okay, it's done building. This is a small, I think there are like 917 reviews, something like that. It's under 1,000, so it's not a lot of words. And if I scroll up here, we're going to see our predictions. So beer, synonyms, quote unquote, synonyms is not really right here, because remember what Curtis said. This is showing that these words are showing up in the same context, right? So if I gave it more information, it would give me better predictions. It's giving me dancing, drinking, bottled, Coke, and volleyball. Okay? Yeah, I mean it's not bad for the size. I've actually earlier it was getting better results, and that's another interesting thing about this. So if I haven't got you excited about trying this out yet, this is a non-deterministic algorithm, which means that you can run this thing over and over again, and you'll get different results, slightly different results, or wildly different results. And so that's kind of an interesting thing, but it's fun to kind of take this and try it out with things. Let me go back to let's try another example. So obviously this is hotel reviews, so the word hotel is going to be in here quite a bit. So let's see what it comes up with for that. Gonna run it again. Actually, if I don't delete the model, yeah, it'll be fast. Yeah. Okay, so for hotel, it came up with property, place, resort, omni, and city. And let me show you one more that so far has had pretty good success. If I look for something like Marriott, run that thing. let's see, what did we come up with? Henderson's, Boston, Hilton Inn, Marriott with a 1 T instead of 2 T's. Okay, so not surprising that that would show up there, but it's actually doing a pretty good job. And this is one of the things about machine learning that I always tell people is like, and somebody asked a question that is kind of similar to this. Like machine learning will do something, you give it inputs and it'll give you something back. But what problem you're solving with it is kind of like, it takes quite a bit of experience, it takes quite a bit of looking at the results and doing things, and that's why, Curtis always, I've seen Curtis give his machine learning talks on various topics before. It's usually, there's something in there that sort of tries to give you a perspective that you're not just gonna build this thing and then go off and ride into the sunset and it's gonna work forever, right? It's sort of like there's always a sense you can do better, you can tune it more, it might, do really strange things, it might, you might use techniques to solve problems different ways, so it's really a very interesting topic area. Okay, I have another example where I just show the same thing from the command line. Earlier I didn't talk about this, but there's a nice Spark command line. Everything I'm running right here is running locally on my laptop, but you can also use like an interactive mode with Spark. If you want to start a REPL kind of interpreter there and type stuff in, you can do that. That gets old fast if you're doing something complicated, but if you just want to look at something real quick, what's the first thing in my nickel query? What's the first row? That's a lot easier. Okay, so that's it for me. Are there any questions here? Anything I can answer? Are you totally impressed? I hope so. If you want to try this out, like I said, I'll put this out. The Spark connector stuff is on, well, first of all, it's on Maven Central. You can just get it through SBT or whatever build tools you use. But if you want to check out the source code, it's up on Couchbase GitHub repo. The code samples are on Couchbase Labs GitHub repo, including this one that I just showed you, in case you want to modify it, try out your own words, find out what the swimming pool synonyms are. There's some talks online here that are linked in, and there's a more sophisticated market basket analysis sample application that was done with the Spark connector, done by a partner of ours called Avalon, and that's kind of a cool one to look at. It's got a nice write-up if you're interested in more complex things. I like this Word to Vec because you can do it real quick, and you can run iterations on it. You can try different things out. So that's it for me. I'm available on at Will Gardella on Twitter, or can email me will.gardella@couchbase.com. If there are any questions, I'll answer them. Yes.
I guess the NoSQL databases are becoming popular. Would you say that scalability focus, is that your main advantage area, why we would pick you over some other database?
Scalability is definitely one. Another one is cost, the operational ease of operations, kind of those things that were on that slide earlier when I was saying the speed with which you can develop, the flexibility for applications teams, right? If you go out and look at what a lot of big application companies do, a lot of times you'll see that it's either NoSQL or it's something like MySQL used like a NoSQL database, right? They'll strip off everything else so that it scales, right? So there are a lot of different things that people do, but a lot of times it's bigger applications that'll use this. Not only, but a lot of times. Other questions? Okay, well, thanks so much for coming, guys. Curtis is here answering questions. Okay, thank you.